important to know that tomorrow you're not expected to do problems as complicated as what some of these are on the review. So concept is important. On number 1, remember tomorrow no calculator. You would take 13 and divide it by 32, and we would use long division to do that. 32 doesn't go into 13, but 32 does go into 130 4 times. And we would multiply. So 4 times 2 would be 8. 4 times 3 would be 12. And then we would subtract, and we'd bring down the next 0, and we'd see that it doesn't go into it again. So it leaves me kind of between here and here, and for the sake of time on this, you can see the method, and tomorrow's problems won't be this long. We'd take 13 divided by 32, and we'd get 4.0625, which is why C is the correct answer. Okay. Which fraction is equal to a repeating decimal? Again, the numbers like this won't be as hard tomorrow, but before I did anything with a fraction, I certainly would simplify it. 5 over 80 would simplify to 1 over 16, which is 0.0625. 11 over 88 would simplify to 1 over 8, which is 0.125. 17 over 85 would simplify to 1 over 5, which is 0.2. 18 over 81 is the same as 2 over 9, which is 0.2 repeating, which is why D is the correct answer. Which of the numbers is a perfect square? If it is a perfect square, it means that I can take the square root of it, which is why we've spent so much time talking about the list of numbers that creates perfect squares. Remember, this side actually is a perfect square. And we'd have to work our way up the list until we came up to 256, because 16 squared equals 256. Number 4 is simple. Don't make it more complicated than it is. If the square root of n is 3/2, then where I see the square root of n over here, I can replace it with 3/2, which is why A is the correct answer for number 4. Number 5, a square playing field has an area. Remember, for the area of a square, you take the side and you square it. And notice it says about how long is each side. Well, this is about 12. 12 squared would be 144. Certainly nowhere near the 1,255. This is pretty close to 3, but 3 squared is only 9. Certainly nowhere near that. These are kind of stuck in the middle, but 35 squared is 1225. You can see that's pretty close. 55 squared is 3025. Also too big, which is why C is the correct answer. We talked about number 6 in class today, even commented that these numbers, C and D, are awfully close together, and you won't be expected to know that tomorrow. But the method of how to do this is important. The square root of 35, we look for a square root that's greater and less. We know the square root of 36 is 6. And we know that the square root of 25 is 5. It's much closer to this 36, but it's definitely between 5 and 6, and it's more than halfway up, so it's between 5.5 and 6. That eliminated A and B as an answer. The next thing that you'd want to do, and again, tomorrow it's not this difficult, is actually see which one, 5.91 times 5.91, or 5.92 times 5.92 would get me closer to 35. Well, 5.91 squared is 34.9281. 5.92 squared is 35.0464. This one's 0.0464 away. This one's let's see, 34.9281 and 35.0719 away. Which is closer? Well, since this one's 700ths and this one's only 400ths, 0.592 is closer. Again, remember tomorrow it probably will say which integers are closest. And the integers that this would be closest to would be 5 and 6. It's between 5 and 6, and it's closer to 6. In order for a fraction to become an integer, it would have to divide into it evenly. No matter what number I put in the denominator of 17, it certainly would have to be less than 17 if I divided it by 1, or if I divided it by 17, it would become either a negative 17 or it would become a negative 1. However, if I try to put any of these other numbers in the denominator is larger than the numerator. It's no way can be an integer, which is why the correct answer is D. Which of these is most likely to describe the change you received back from cash? A purchase? Well, most likely you're going to purchase something that's some dollars and cents. Maybe it's $2.11, and you give them a $5 bill. Most likely you're going to get some coins, in other words, a fraction of a dollar, and you're going to get some dollars back. So it's not likely that you're going to have something that comes out exactly $1. It's not going to be a whole number. There's no way they're going to take money away from you. It's not going to be negative. There's no way that they're going to give you the square root of 2 change back or pi change back. So most likely the outcome would be a rational number. Which of these terms for set A makes this diagram true? Since this says irrational, there are no sets that are subsets of the irrational numbers. So this would be D, none. Which statement is false? Some integers are irrational. Again, if you remember what our Venn diagram looked like, everything was real. We had irrational, and we had rational. Inside of the rationals, we had integers. Inside of the integers, we had whole. Here it says some integers are irrational. Well, that's definitely false. All integers are rational, and it can't be both rational and irrational. So this is definitely a false statement. I told you you would not have a problem like 11 and 12 where you were having to do something like pi and the square roots plus or minus some fractional piece. So please don't worry about 11 and 12. 13, although you might have a problem that's similar to this, it says equal to a terminating decimal or a repeating decimal. You'd actually take 128 and divide it into 11. And it does become 0.0859375. Now, because it's like this, you won't have one that's this long. You might have something like 3/8 or 2/4, where you don't have to do this amount of division. But because it does have an end, this is a terminating decimal. Right, 2 and 1/16 is a decimal. Well, the 2 is going to be in front of the decimal. And we're going to take 16 and divide it into 1. Well, obviously 16 doesn't go into 1, nor does it go into 10. So we'd add another 0. And we're going to find that this comes out to 0.0625. Just as a reminder, tomorrow there's no calculator, but I will limit the amount of times you have to do division. You probably won't see more than 2 or 3 places as far as a decimal is concerned. Express the fraction in decimal form. This is done the same way. We're going to take 11 and divide it by 30. This goes into it 3 times, which would be 90. 30 goes into this 6 times, which would be 180. And there we can see what's going to happen again. It's now going to repeat. So this is 0.36 with a bar over the top of it, because it would be a repeating decimal. Number 16 we talked about in class, and again, maybe kind of long, because when you do this division, 7 into 3, it comes up to 0.428571 and 428571 all repeat. Although you may have this type of problem tomorrow, again, it will not be something that repeats 6 digits, because there are 6 digits that actually repeat here. Find the 2 square roots of 9 over 4. Here they're not talking about just the principal square root, but both of the square roots. And when we were talking about square roots, we said that they often got a positive and a negative result. So we're taking the square root of 9 over the square root of 4, which would be the same as 3 over 2. But it's possible that not only would I get a 3 over 2, but I would also have a negative 3 over 2. There are my 2 possible square roots. The principal square root is positive. The other square root is its opposite. A number line is numbered in tenths. Describe where you would plot this. So, the square root of 87, and I'm going to just drop the 0.35 for a minute. On each side, square root of 81, square root of 100. This would be 9. This would be 10. Right in the middle would be 9.5. This is 6 units away. This is 13 units away. So it's closer to the 9 than it is to the 10. So it's definitely in this half. So it's 9.1, 9.2, 9.3. It does come out to 9.3 to the nearest 10th. I won't be having you calculate something to the nearest 2 decimal places. But again, remember that when you're estimating a square root, that what we're looking for is the square root that's on both sides of this. The square root of 225, which is 15, and the square root of 256, which is 16. And again, right in the middle would be 15.5. Here it's 25 away. Here it's only 6 away. It's definitely on this end and pretty far up as far as its closeness to this 16. And we would find that this is 15.81 to the nearest hundredth. And again, I just punched that into a calculator. But if you can get to the nearest tenth, if you had 15.8, if you had 15.7, if you had 15.9, I certainly would accept it. Classify the square root of 64 over 5 as a whole number, integer, rational, real. The square root of 64 over 5, the square root of 64 happens to be 8. And 8 divided by 5 would be 1.6. So it's definitely not whole or an integer, but it is rational because I could find the value of the square root. It says write the principal square roots of the integers. So they're saying write it out. The square root is 320, implying that it's positive. The square root of 321, square root of 322, the square root of 323, the square root of 324, and the square root of 325. And it says which of these is rational. In other words, which one can I find the square root of? And again, if you have your chart memorized, 18 squared is equal to 324. So the square root of 324 is equal to 18. So this is the one that's actually an integer. All the rest of them are irrational numbers. Okay, 22 through 24, I said to cross out. Don't worry about these. Just real quick, which formulas contain a rational number that is not an integer? If I were looking at the formulas, I would say 1/2 is a rational number. 4/3 is a rational number, and those aren't integers. So the area of a triangle and the volume of a sphere would answer number 22. Which of the formulas contain both a rational number and an irrational number? Well, pi is irrational, but they also want a rational number with it. So the two that contain a rational number with it are the ones that have the 4/3 and the 4. So the volume of a sphere and the surface area of the sphere. And what kind of numbers would not make sense sensible for the values of the variables. If I'm talking about the variables themselves, and they say what kind of numbers wouldn't make sense for them, any negative number would not make sense since they're talking about distance. But again, remember these you don't have to do. Number 25, find an integer between the square root of 30 and 4 pi over 3. The square root of 30, square root of 25, square root of 36. So I know that it's between 5 and 6, and it is just a little bit closer to the 25 than it is 36, so it's probably 5.4 something. We're going to keep that in mind for a minute. 5.4. 4 pi divided by 3. Again, since I'm just estimating, if this pi had a value of 3, these would actually just cancel out. So 4 times just a little bit more than 1 would be 4 point, maybe 1, maybe 2, but 4 point and a little bit. So I'm looking at between 4 point something and 5.4 and asking myself, what integer exists in between these two places? And 5 does. That's why 5 is the correct answer for number 25. Number 26, arrange the numbers in order from least to greatest. We'd want to look at them in decimal form. So this would be 11.4. 4 times 3.14 would be 12.56. And the square root of 150 is between the square root of 144 and the square root of 169. In other words, it's between 12 and 13. 12.5 would be directly in the middle. It's only 6 away from 144. It is 19 away from 169, so it's less than 12.5, but more than 12. For the sake of argument, that gets us close enough because I know that I'm between 11.4 and 12.56. So listing them in order, 11 and 4/9 is my smallest. The square root of 150 is next, and 4 pi is the largest. And notice what I just did, didn't read the question. It says greatest to least. Greatest is what? 4 pi. The middle is the square root of 150. And last would be 11 and 4/9. Make sure that you read the question. This is